Before entering our kitchens, the humble onion, a staple of global cuisine, goes through a fascinating transformation. The days of traditional, labor-intensive procedures are over. Large-scale onion processing is dependent on a complex interaction of specialized technologies, scientific concepts, and stringent quality control. This in-depth examination digs into the sophisticated industrial process that converts raw onions into the chopped and sliced ingredients that power our culinary inventiveness. A historical context, the onion's enduring allure. Historical proof reveals that humans have been cultivating onions for nearly 5,000 years, with origins in ancient Mesopotamia and Egypt. Greek athletes believed onions had blood-thinning powers, while Roman gladiators used onion mixtures to increase muscular tenacity. The onion rose to prominence as a kind of currency during the Middle Ages, being traded alongside valuable metals such as gold and silver to pay rent and obtain commodities. This historical significance highlights the onion's continuing allure, which extends beyond culinary applications. Today, the onion is a staple in various cuisines around the world, bringing depth and complexity to dishes as diverse as French onion soup and Indian curries. Before we get into processing procedures, we should handle the onion's tear-inducing characteristics. When an onion is chopped, the cell walls rupture, releasing the enzyme alliinase. Syn-propanethyl S-oxide is a volatile gas produced by the enzyme when it combines with sulfide. This gas irritates our eyes' lacrimal glands, causing tears to flow to remove the irritation. Modern processing techniques address this tear-inducing phenomenon. However, understanding the underlying biochemistry allows us to appreciate the ingenuity behind the no-crime methods employed in factories. Detailed analysis. Large-scale onion processing. Large-scale onion processing is a complex operation that prioritizes efficiency, quality control, and safety. Here's a full overview of the essential steps involved. Mechanized harvesting. Automated harvesting has replaced physical labor. In enormous fields speckled with millions of bulbs, specialized harvesters known as onion lifters and windrowers take center stage. These devices work with incredible precision, limiting damage while increasing productivity. Onion lifters. These gigantic vehicles use a succession of meticulously calibrated blades to gently break the roots beneath the bulb, enabling a smooth separation from the earth. Consider a high-speed, synchronized ballet between blades and ground, carefully separating the onions without causing nicks or bruises. Windrowers. Once lifted, the onions are dumped on a conveyor belt that feeds into the windrower. This machine gently shakes and flips the onions, removing them from any loose soil that clings to the bulbs. Consider it a massive mechanical sifter that guarantees a clean, debris-free harvest. Curing. This is an incredibly crucial stage for preservation. After harvesting, the onions are dried under regular conditions, usually beneath the summer sun. Curing is a key procedure that permits the onion's outer layers to dehydrate, basically putting on a protective travel coat. The curing process, despite appearing simple, necessitates careful monitoring and modifications dependent on environmental conditions. Factors like temperature can affect a lot more than we expect. Excessive heat while curing can cause sunburns on the onion's outer layers, which affects both appearance and shelf life. In contrast, chilly temperatures might impede the drying process, thus increasing the danger of spoiling. Sensors and automated control systems are frequently used to keep curing temperatures at their appropriate levels. Humidity. High humidity levels during curing might provide a breeding environment for mold and germs. In contrast, extremely dry circumstances might cause the onions to dry out too rapidly, compromising their texture and flavor. Achieving a balance between temperature and humidity is crucial for effective curing. While sun drying remains a popular curing procedure, other methods are also used. Forced air curing. This method involves enormous fans circulating warm air around the onions, hastening the drying process. This strategy is particularly useful in areas with unpredictable weather patterns. Barn curing. Onions are stored in well-ventilated barns where they can dry naturally and under controlled conditions. This procedure is frequently used in tandem with standard sun drying. Curing is a fascinating scientific concept. Onions have a high moisture content, and their outer layers are naturally more prone to rotting. The curing procedure eliminates excess moisture and forms a natural barrier against mold and germs by enabling them to dry under controlled conditions. This not only increases their storage life, but also assures that they arrive at the factory fresh and ready to be processed. Factory processing begins. When the onions arrive at the processing facility, they go through a thorough examination and sorting process. Optical sorting system. These advanced systems use cameras and algorithms to detect and discard broken, discolored, and undersized onions. Consider a high-tech sorting machine with a keen eye, ensuring that only the highest grade onions advance through the processing chain. Human sorting. While optical sorting systems are quite successful, some facilities may use human sorting lines for a final quality check. Experienced staff visually analyze the onions to remove those that may have snuck through the automated system, shedding layers with precision. Peeling procedures are chosen based on the intended final output. For example, French fries. For perfectly golden French fries, consistency is king. Imagine a plate of French fries, each one a slender, golden soldier standing tall. To achieve this uniformity, the peeling process for these onions prioritizes achieving a consistent outer layer thickness. Compared to other applications, French fry onions might undergo a more aggressive peeling process. This could involve a combination of techniques, such as high-pressure air blasts. Powerful blasts of air can effectively remove several layers of dry, papery skin simultaneously. Specialized rollers with varying textures. Rollers with specific textures and pressure settings can be employed to remove outer layers with greater precision. Imagine a series of rollers, each with a slightly different surface texture, working together to achieve the desired level of peeling for consistent fry results. Onion rings. Onion rings necessitate a different strategy. These gastronomic marvels are built on a strong onion base that can resist the rigors of breading and frying without falling apart. These peeling processes focus on keeping a thicker outer layer. Selective peeling techniques. Techniques such as air blasts or specialty rollers may be modified for a more targeted approach. Instead of eliminating all of the outer layers, these procedures may leave behind a somewhat thicker layer for structural stability. Blade trimming for precision. In some circumstances, precision blade trimming may be necessary to produce the correct thickness for the onion ring base. Consider a competent craftsman using a specialized blade to precisely remove just enough of the outer layer to keep both structural integrity and visual beauty. Specialized peeling procedures can be used to achieve this. Customization options extend far beyond French fries and onion rings. Here are some further instances. Diced onions for sauces and soups often require a finer dice. This peeling process may include a combination of air blasts and rollers to obtain a uniform thickness for consistent cooking durations within the diced products. Onions intended for salads or garnishes may require a softer peeling process to preserve a thicker outer layer, preserving visual appeal and keeping the slices from becoming too fragile. It's vital to note that attaining the best peeling results requires a delicate balance. Removing too little of the outer layers can result in unwanted dry skin on the finished product. Overpeeling, on the other hand, can result in excessive waste and damage to the onion's interior flesh. This personalization enables a varied selection of high-quality onion products to reach our kitchens, ready to impart their distinct flavors and textures to numerous culinary creations. From tearful chefs to tear-free triumph, unveiling the secrets of no-cry chopping. In large-scale processing facilities, the iconic image of a tearful chef chopping onions is no longer seen. Modern factories use ingenious no-cry chopping techniques that are engineering marvels, ensuring both worker comfort and product quality. Water jet cutting, precise slice with a liquid blade. This novel method, known as water jet cutting, transforms the onion processing industry. Water jet cutting uses a pressurized stream of water to precisely cut through onion flesh. The water water stream functions as a miniature, high-powered knife, severing onion cells with incredible precision. This eliminates the need for traditional metal blades entirely. Water jet cutting provides various advantages. Reduced browning risk. When traditional metal blades come into contact with onion flesh, they can oxidize. Water jet cutting completely removes this issue because the water stream does not come into direct touch with the flesh. This results in a cleaner-looking end product. Minimized waste. Water jet cutting is more exact than traditional chopping processes, resulting in less product waste. This is because the water stream can be precisely regulated, allowing only the required area of the onion to be chopped, cutting in a controlled atmosphere. Not all factories use water jet cutting technology. Some factories may apply a different method known as controlled atmosphere cutting. It resembles a high-tech air purifier specifically intended for onions, filtering out the irritant in controlled atmosphere cutting rooms. The air is thoroughly filtered to remove airborne allergens, particularly the lacrimatory element that causes those tearful times. This allows workers to use typical cutting methods, such as high-speed revolving blades, without experiencing eye irritation, maintaining freshness. Controlled atmosphere cutting rooms frequently use cold temperatures, simulating a refrigerated environment. This preserves the onion's freshness and reduces spoiling during the chopping process. Water jet cutting and controlled environment cutting represent important advancements in onion processing technology. As these technologies grow, we should expect to see even more efficient and inventive approaches emerge. Depending on their final destination, the onions are meticulously chopped into different sizes using razor-sharp blades or even water jets. They are waiting for their final destination, which could be a restaurant dish, a pre-made salad, the wonderful onion rings you love, or any number of other culinary concoctions. The next time you bite into a perfectly sliced onion, take a moment to appreciate the incredible journey it took to reach your plate. From the vast fields where it was carefully nurtured to the high-tech factories where it was processed with precision. It's a testament to the remarkable advancements in modern agriculture and food processing.